Welcome back, everyone. Let's go ahead and go through the solutions for the Seaborn exercise questions. Okay, here I am at my copy of the Seaborn exercises notebook. I'm going to run the top cell to do the appropriate imports, and then let's go ahead and read in this application record.csv file and head straight to the first plot. So, first plot was the scatter plot shown below, but there's a couple things to keep in mind. One is that we're only showing people that are employed, and then two is the fact that days birth and days employed are actually shown here as positive numbers, when in fact in the data frame they're actually negative. So lots of different ways we can attempt to fix this with pandas, but first off, let's go ahead and do the following. I'm going to create another data frame called employed. And the way I can figure out who's employed or not, based off the way this works, is simply saying, get me the data frame where days employed is less than 0. Because if you have 0 days employed, that means you're not employed the way this data frame works. Recall, days employed, if we scroll back up here, it's a negative number. Basically, since today, going back, how many days have you been employed? So if somebody was unemployed, that means this value would be 0, since it's been 0 days since they've been employed. But for example, this person, it's been 4,542 days that they have had a job and have been employed. So that's why this is a negative number. So to get everyone that's employed, I'm essentially looking for everyone where days employed is a negative number, indicating the fact that they have some sort of employment status. So we have everyone with the negative number that's been employed. Now what I want to do is, in order to plot this on two positive axes, I simply am going to flip the sign of days employed as well as days birth. So we're going to say here, from the employed data frame that I just created, say that days employed is equal to employed days employed times -1. So that's going to flip the sign for all of that. And keep in mind, you may get this issue or warning of a value is trying to be set on a copy of a slice of a data frame. For this case, that's totally okay. It's basically just telling you that employed right now is kind of still pointing at this original data frame, which is a filter, and now you're kind of resetting based off that. But now if we actually take a look at days employed and take a look at that series, you'll notice that they are actually all still positive. So if you get this error, don't worry about it as long as the results are what you expect. Okay, so that's days employed. The other one we have to fix is days birth. So I'm going to say days birth for this employed data frame that I just created is essentially the same thing. Take employed, take days birth, and then multiply that by -1. It's going to get the same warning again, but now if I take a look at the two columns that I'm actually interested in, which is going to be days birth, comma, and days employed, we run that, and we can see here, now I have positive results. Okay, so let's actually get to plotting these in a scatter plot. How do we do that? We just simply call SNS scatter plot. I'm going to say my data is equal to the employed data frame, y is equal to days employed, and then x is equal to days birth. If you just run it like this, and you were able to get this far, then that's pretty much as far as you really need to go. As long as you figure out, oh, I need to do a scatter plot, and I can see the relationship here, then for me, that's a success. But we have a couple of issues here that we can really fix this further. One is maybe the size isn't really too good. So what I can do here is start editing it just with the figure. I can say PLT figure, maybe say fig size is equal to something like 12 by 6, something like that. And then maybe even increase the DPI. Run that. And keep in mind, this is going to take a little more time the higher the DPI goes, just because there are so many points. You don't want to go too high here with the DPI, otherwise that'll really slow down your computer, especially if you're running on something with lower RAM. And something to note here is with our higher DPI, looks like we're seeing all the points really clearly, but the issue is we still have a ton of overlapping points. And you'll also notice that pretty much each of these dots actually has a line width of a white line surrounding it. So there's a couple things we can do here to fix this. We can say alpha is equal to some very low value. We can even set this as something like 0.01, so there's a ton of transparency here. And the alpha value you choose should probably be dependent on how many points you actually have, which you can check simply by saying, what's the length of my employee data frame. And if you look at this, you're actually plotting out 363,000 points, which sometimes may be a good indicator that you shouldn't use a scatter plot. Maybe you want to use something like a joint plot and use the hex plot or some sort of KDE plot to show this distribution. But anyways, if we are going to use a scatter plot, definitely want to choose a very low alpha, and also probably want to get rid of this line width parameter so that it's not as thick. And maybe let's go ahead and lower the DPI since we don't need it to be that sharp, since we're going to encourage that alpha parameter. So let's go ahead and say 150, run this again, and then we start to see the plot that we just created up here above. And for our use cases, this is pretty much exactly where we want you to be. Get rid of that line width and then have a very strong alpha. And we can see here there's tons of overlapping points here, which hopefully if you're getting better and better at visualization, might be a good indicator that a scatter plot is not the best way to show this information because it's essentially just showing kind of this solid block. Okay, part 2, recreate the distribution plot shown below. So for this one, the tricky part was how do you figure out the age and years when you're only given this kind of weird negative days of birth number? Well, that one's actually easier than you may think. You simply are just going to call a histogram plot. And then what you can do here is the following. We're going to say df, and then we can say something like years is equal to df days birth, and then we're going to say take -1, multiply it by days birth, and then to get years, divide it by 365 days. So we know there's 365 days in a year, so if you divide it by 365, that should get you the years, and then we say -1 to make sure it's actually in positive numbers. Once we have this years column, then we can simply say something like data is equal to df, and x is equal to years. And if you run that, and if you can get that far, this is pretty much all we really wanted you to do. The rest is just styling and sizing. So for example, I can start editing the bins to be something like 45. I can say the edge color, well, I think it's already black, so if we just lower the number of bins, we're starting to get to the same place. Maybe the color, you can say it's either red or pink or something like that. So we can see here, starting to kind of match this color. This one's a little darker. We actually used red with an alpha value in the solutions notebook file, but kind of up to you. But as long as you can see here that you're getting the same thing, this is essentially the exact same plot. And you can always resize it yourself. So the tricky part here was figuring out, oh, you need to actually create the years column in order to plot this out. Or if you really wanted to, you could actually technically just pass in this instead of data and x is equal to years. All right, moving along, recreating this categorical plot shown below. So hard part about this one is we're only showing the bottom half of income earners. So that means we have to actually get a separate data frame for only the bottom half. There are tons of different ways you can do this, but one way, if you remember the methods on our data frame, we have this n smallest method, which recall is going to return only the first n rows ordered by a particular column. So what we can do here is the following. And again, this is not the only way to do this. There are many ways. You could just say sort by and then take half of it. But if I know the length of my data frame, essentially I know there's around 438,000 rows. What I want to do is say n smallest and set n equal to half of this value. So if I say this divided by 2, it looks like more or less 219 rows. So I can say right here, n is going to be equal to this value, half of my data frame. And if you want, you could just say integer and then pass this in directly, formulaically, instead of just the raw number. And then what I want to do here is say columns is equal to, and in this case, I'm interested in amount, income, total. So amount, income, total. And so what this is doing exactly is saying, grab me half of the data frame for the people with the smallest amount, income, total. So this is essentially the bottom half if you sorted by amount, income, total, which is another way you could have done this. You could have instead say sort values by amount, income, total, and then just grab the either bottom half or top half, depending if you sorted on ascending or descending order. But this is another way of doing it, which is n smallest, essentially the exact same operation. So let's actually call this bottom half income. So we set that kind of as a new data frame. That way now I can say sns.boxplot, and then I say data is equal to this bottom half income, and then what else do we want here? We want y equal to amount income total, and then I want x to be the category of name, family, status. And recall we also have this hue parameter where the hue was this flag own realty, whether or not they actually own property. So we're going to say flag own realty, so that matches up. And pretty much if you got this far, that's basically the gist of the plot. So we run this and we get back this box plot. And now from here, it's just editing the style and making sure it looks nice. So first thing, probably want to edit the size. So I'll say PLT figure is fig size. Let's go ahead and say fig size is equal to 12 by 5 or something similar. And we'll sharpen up the DPI a little bit. Okay, so this is starting to look nicer. Notice that legend, it's still inside. We already know how to fix that. We simply say PLT legend, and then I locate it outside. I can say location is equal to, let's say 1.05, and if you want, we can just have it kind of in the middle. Okay, and whoops, this should have been PLT legend with a D. There we go. Okay, so now the PLT legend is outside, and if you want to keep adding stuff to this legend so that it's titled, so if you want, you can say title is flag own realty. That way you actually know what this legend is representing. And finally, a really common questions that, whoops, spelled this wrong, should be flag. And so finally, before we move on, something I want to point out is a really common student question when it comes to box plots and trying to match up with a box plot that they've seen is how to specify the X tick order here along the groups. And the way to do that is it's actually really simple. You just expand on this and you'll notice there's this order parameter. And the order parameter, if you scroll down, it basically just says that it wants a list of strings, which is essentially just a list of these column names in the exact order you want them. So for instance, you could say order is equal to, and then just start writing the column names in the order you want. Thing is, they have to match exactly with these values. So we'd say, okay, first I want married, then maybe I want widow, etc. And you would keep going until you filled out all the possible X ticks in the exact order that you want them in. So that's one way to make sure that your box plots are in the order you desire. Okay, so finally we wanted to recreate this heat map shown below, which is just showing the correlations here. And so if we actually say df.core, this will relay back the correlations. You'll notice that because of the way it's written out in the data frame, this flag mobile has a bunch of null values because it's missing a bunch of stuff. So for that, we're simply going to say df.drop the flag mobile column. So we'll say drop flag mobile along axis is equal to 1. And now we can see all these correlation values here. And we'll go ahead and include ones that kind of don't make sense, like the correlation of the ID. And then just say SNS heat map, run that, and we get this heat map. And if you want, you can change the color mapping of CMap to match this. Okay, so the reason I just added this last question, because it was pretty simple, you just had to figure out to call .core as it mentioned in the instructions and then call .heatmap on it, is we're going to often actually do a heat map on the correlation of features within machine learning to see what features are good candidates for trying to predict a label. So this is actually an operation you'll see us do a lot, is create a correlation data frame and then use the heat map so I can quickly point out visually what's important and what may not be so important. And you can always annotate this with annote is equal to true, so you can actually see the values. And if you want, then you can expand on this size, add DPI. Not right now. This is probably not the right figure size to annotate values because of how far the significant digits go. So just keep that in mind. You can always edit plot sizes and figure sizes and even text sizes. It's all available for you in the Seaborn documentation. Okay, if you have any questions, feel free to post to the Q&A forums. If not, I'll see you at the next section.